Hello everyone and welcome to How the Magic of Open Source Helps Our Project. My name is Daniel Espino García. I am a software design engineer at Mattermost. If you want to contact me, feel free to drop by the office at Mattermost community server. Before we start, let me tell you a story. Imagine you are using a program. You only have the binary, so you cannot look inside. And you want to know how it will behave. The only way you can do that is by looking at the documentation or experimenting. You could also try Stack Overflow or ChatGPT to see if you get the answer. But maybe your question is so deep that they cannot answer it neither. And experimentation can give you an idea, but you cannot know for sure. Wouldn't it be great if you could see how the program was made? If you could look beyond the black box and tap into the essence of the program? Wouldn't that be like magic? Ladies and gentlemen, that is part of the magic of open source. Here is the agenda for today, and without further ado, let's start. What is open source? Let's start with a few misconceptions. The first misconception is about the word free. Sure, most of the open source code that is out there you can get for free. But the free word is about freedom, not about cost. If we go to the open source initiative definition, the main part of the freedom is the freedom to redistribute the code, not about that being free. Another common misconception is that open source community can be your free labor. They will test and contribute to your project, and you don't have to pay them anything because that's how open source works. No, that may happen, but it's not how it works. You need to have a good product or library. People have to find it, people have to use it, and people have to see potential in it. So it's worth their time contributing. And all that is not free. And when you get to the point where they start contributing, you still have to keep control of your library. Review the pull requests, discuss the changes. Sure, it helps, but it's not free. Next, you could ask, how can you sell something that is free? Well, there are many ways. Among other things, it's not only the code that you are selling. It is the whole product, or sometimes a service. There are out there big profitable companies that are open source like Red Hat. Others like GitHub use an open core approach that I will talk about later. And other huge companies like Meta or Microsoft have a big part of their code also distributed as open source. So looking at examples, yeah, it seems that it is economically viable. Finally, some people will say that open source is a niche, something just a few people use. But according to some sources, 90% of the code you have out there uses open source one way or another. Sure, oftentimes it's used to create proprietary code, but still used. So not really niche. So yeah, we know everything that is not open source. But what is open source? I'm going with an adaptation of the open source initiative definition. What I feel is more important are these points. First of all, the code of the software has to be available. You must be able to look at the code of what you are executing. Next is derived work. The license must allow creating derivative work out of the code and distribution under the same license. This can be under different restrictions based on the license, but in general, it's about being able to use the open source code in the project. Another important one is that the distribution should not discriminate. Everyone should be able to use the code in any field and with whatever technology. And finally, one that is really useful for us everyday developers, free redistribution. people is free to redistribute the code as an aggregate of programs. That is what brings us tools like NPM to us. But what kind of open source exists out there? One way to look at it is about openness. The most pure way of open source is that open source, what we have already talked about. Then you have open core, which is a mix of open and closed source. The core of the product must be usable as a standalone and be open source. The rest of the add-ons may be closed code. With that in mind, you could differentiate between open core with a thick closed layer and open core with a thin closed layer. For example, as in Mattermost, I will say that more than 90% of the code is open source, with a thin layer of closed code. Apart of that, you may have code available. That is not really open source, because the license on top of this code forbids the use and distribution of the code, but you are able to look at it, making the code visible, which is also really interesting. Then you can look at the licenses. Regarding licenses, there are tons of different licenses, each one with its own quirks. For example, the GPL license forces that any derivative work must be released as a GPL license. The BSD one allows you to modify and distribute the software as long as you keep a copy of the original copyright notice, list of conditions, and disclaimers. Finally, the MIT one is one of the most lax, allowing you to do all the changes you need as long as you keep a copy of the original license and copyright notice. And well, now that the history lesson is over, let's get down to business. Open source is great, and it will be great to use it in our project. But how do we do that? Do we have to go to every GitHub repository and download it? Well, kinda, but not really. That is where package managers come into place. There are out there many repositories of open source libraries. Each language has their own. But I'm going to talk about one we use at Mattermost, NPM. NPM stands for Node Package Manager. But as they say on their website, it's not only that. It also has a registry of open source packages to use on your apps. And finally, it is also a command line client to use or publish those packages. NPM tracks all your dependencies and helps you install all the different things you need to make your code work. And where does it all go? To the Node modules folder. Every single package you need, including their dependencies, will be downloaded and thrown into the Node modules folder. This you see in the slide is just part of the contents of the Node modules folder in our mobile app. It is overwhelming the amount of code we are using that we didn't write ourselves. And all this code will be compiled and sent over with our application without any cost. And part of that is thanks to the concept of open source software. But what is inside this? Let's take a deeper look at the library, at one library. For example, the base64 package. As you can see there, we have the full code for us to see. And here is where the magic of open source I was talking about starts to happen. So, we have all that code there. And how can we use it? Understanding what happens beneath. For this section, I want to put you into a real example. At some point, we noticed our app was mixing images. It didn't happen often, so it was really hard to reproduce. But we were able to pinpoint the issue down to one of our direct dependencies, FuzImage. But more interestingly, it only happened on iOS. If this was closed code, we may be able to use a binary of FuzImage library in our code. And when we face this problem, our only choice will be to send an email complaining how their library is causing problems. But with open source, we are able to get a bit deeper. When we get to the Node modules folder of the FastImage library, we see this. The JavaScript side mainly uses the native component. And since our code only fails in iOS, it makes a lot of sense our problem is over there. But when we go to the native code, we see this. FastImage is implementing an element from another library, SD animated image view. So we found our problem was not directly related to FastImage, but an underlying library. We were able to go even farther down looking at the code of this library. And well, yeah, we didn't fix the issue, but we were able to post in their repo about this problem. And a few versions later, the issue was fixed and ready for use in the newest version. But it's not only about tracking bugs. Sometimes, yes, you want to learn more. For example, should you flatten your styles before passing them to components in React Native? The only way to know that is to see the underlying implementation. This is not something you can do with closed code, but here it's way simpler. We go to the library and see how things are done under the hood. In this particular case, we see that all basic components in React Native are calling flatten style either way. So calling it ourselves helps at apparently nothing. Sometimes the libraries are distributed in a minimized way, making it really difficult to understand what is going on. Let's imagine we want to check how expensive is using a use memo in our components. We want to get some extra performance, but will use memo really help? And at what cost? So we dive into the node modules files of React, and we find, among other things, this. Okay, yeah. As you can see, hard to see what is going on here. But do not fear. What we can do is go to the actual code. How we do this? Probably a Google search will take us where we want to go faster, but let's do it the long way. First of all, let's go to npm and look for the package. Yeah, the package we're using is React. So there you have the repository link. Let's go to the repository and voila, all the React code at the tip of your hands. After some more searching, making sure you are in the right branch and so on and so forth, you may find this. So the actual function I should be looking for is update memo. And where is that in my node modules? Because I mean, that code is executing, so it should be somewhere in my node modules. Let's take a look. There you are. Apparently, React Native re-implemented this a little bit. And looking a bit into it, you can start grasping the overhead of using useMemo, which, well, in general, is not much. And well, learning is great, but at some point you want to get things fixed. So what can we do? Let's have some real examples about that. What you see in the screen on the left side is the commit history of the latest release version of React Native Reanimated library, one of the libraries we use at Mattermost. And on the right, you can see the commit history of the main branch. As you can see, a lot has happened since. Let's imagine there's a bug that is affecting my application and I need to fix it. And I know the bug is in the library. But great, it is fixed on main, but not on the latest release. If this was closed code, yeah, I wouldn't even know there's a fix in main. All I could do is complain and hope that some point it will get fixed. But since this is open source, we know there's a fix. And that opens several options. The easiest one is just wait for the new release. But sometimes there are bugs more time sensitive. You may have to align to your own release cycles or it is affecting a critical part of your app. Waiting is not always an option. Another option will be to import the library directly from main. Yeah, that's a bad idea. Depending on the project, main may not be the best tested and stable branch. You may be able to afford to add one commit that fixes the problem you have. But do you want to include all other changes that maybe create more trouble? Probably not. One extra option is to create your own fork and cherry pick the change. Then you just have to import your fork and that's it. But then it makes more complicated to keep the track of the new versions because yeah, a new version appears on the main repo, so you have to sync your fork, or yeah, you no longer need a fork, so you change back the reference to import the original library, but then you want to add another fix, so you get back to your fork. Yeah, that seems a lot of work. The option I like the most is patching the package. Let's take an example again, the mixed image problem. I told you that one more recent version of the underlying library, the issue was fixed. But what we are using is the fast image library. We will need to get that updated too. But no, it's no need if we patch the library. We just need to find the correct files in the node module folder, for example, this one, where you see that we are setting the library version, make the changes we need, and run npx patch package. That will create a new patch with the changes that will be used every time I install the library. As you can see on the left, this is something we extensively do in our project. But patches have one more use, changing how things work. Libraries are great, but sometimes you want them to work in a slightly different manner. You want that tweak, that things that make them more yours. Again, with close code, all you could do is complain and hope. And if what you needed is something only you need, you cannot expect the original developer to add it. So you may end up creating your own library just because you needed that small thing. But not with open source. Let me give you an example. React Native haptic feedback library. As you can see here, the different type of vibrations are hard-coded. Probably there are good reasons for that. But we want a vibration that has a special duration. And how we do that? We could rebuild the whole library ourselves so we can have the durations the way we want them. We could create a fork and do that in our fork. Or we can even ask the original developer to comply with our needs and do the things we need. But yeah, all that seems kind of wrong. Let's just patch it. The process is the same as with the fixes. You modify the file in your node modules folder, call npx patch package, and there you have the patch to use the library as you need. Let's look at another example. We use WatermelonDB library as an alternative to Redux to store the state of the app. WatermelonDB uses an underlying SQLite database to store the state. In order to keep the data integrity, it has some checks as the following. You cannot batch elements without changes, and you cannot update rows with pending changes. This is really important, because if not, you may end up with unexpected results. But we needed to go around those limitations. We still want to inform the developer they are doing something out of the ordinary, but if the developer knows what they are doing, we want to allow it. But that is us. Most people should still have those guards. So again, what did we do? Ask the developer to comply to our needs? No, we just patched the package. We made the changes we wanted, so the process continued the way we thought it was the correct way. We keep it contained, so only us do this in the dangerous way, and we don't have to wait for the original library to get a new release out. And well, we're almost at the end. I hope you like this talk and you discover a new phase of the magic of open source and start using it to help your projects. But the reality is that it's not only about the code. That's not only where open source helps your project. When you decide to become open source, you open the door to a community, people that will help your project to improve in many ways. People not only contributing code directly. For example, in Mattermost, we have received tons of localization contributions. Also, being open source helps you to achieve better security and security contributions. For example, with HackerOne bounty programs, or even when a client wants to audit your code, the security of your code, you can just have it there. It's there. You can look at it and see how secure it is or not. We also have a growing community of QA contributors, and that helped a lot during the last Oktoberfest. We also have the community server, where a lot of troubleshooting is done. Many times, not even by members of the staff, but by peers helping each other. And of course, all the people that find and report bugs or propose new features. As you can see, opening the code and opening that door to the community can be a great boost to your project. And if anyone from the community is watching this talk, I want to say thank you. Mattermost wouldn't be the same without you. And another important thing in open source, remember to give back. The simplest thing you can do is open your code. But yeah, I understand that's not always possible. But if you are creating any library or any tool that could be used for more people, consider opening it. Usually that is easier to open than the whole product, and you may be able to help a lot of people out there. The next best thing is to go out there and contribute. Whenever you're using a library, think how you can make it better and try to get those improvements upstream. Your project will be better since the library you're using is better, and you will also make it better for many more people. And if you want to do still a bit more, feel free to donate money to different projects. There are many open source projects out there accepting donations, and that is one way to keep the ball rolling for those projects. And just to summarize what we talked today, a few notes. Get comfortable with how non-modules is organized, or well, if you are using any other language, however that language manages the packages. Do not be afraid in diving into library code. It can help you understand better how things are done under the hood and help you grow as an engineer. Remember that you can fix libraries before the change gets upstream. But yeah, of course, if you are the one fixing it, be nice and create a pull request in the original library. And last of all, remember that if you want a different flavor in a library, you can always patch it so it works the way you want. But yeah, remember that you have patched it. So when you face an issue, before creating the issue directly on the repository of the creator, make sure you didn't introduce the issue with your patches. And well, thank you very much for watching this talk. I hope you like it. And if you want to ask any questions or leave any comment, remember that you can do it at the office at community.mattermost.com. Goodbye.